Toyota is on the brink of revolutionizing the auto industry with an engine that's set to make EVs a thing of the past. This brand new design is like nothing we've ever seen. It's being hailed as the most eco-friendly engine on the planet. So get ready for a game changer as Toyota's groundbreaking technology promises to shake up the car world and send shockwaves through the entire EV industry. Toyota is rewriting the future of transportation with a groundbreaking innovation, a water-powered engine. This revolutionary engine takes inspiration from hydrogen-powered vehicles like the Toyota Mirai, but with a twist that could leave electric cars in the dust. While EVs have dominated the green automotive space for years, praised for their zero emissions, Toyota's new water-powered engine offers something even more remarkable. Instead of relying on batteries and electrical grids, this engine taps into one of the planet's most abundant resources, water. Through the process of electrolysis, water is split into hydrogen and oxygen, which powers the engine. Even better, this can be done using renewable energy sources like solar and wind, making the entire system far more sustainable than traditional electric vehicles. EVs might be marketed as clean, but the production and disposal of their lithium-ion batteries create significant environmental challenges. Toyota's water-powered engine completely sidesteps this issue, offering a truly green alternative. During a recent meeting in Japan, Toyota's Executive Vice President and Chief Technology Officer, Hiroki Nakajima, revealed that Toyota is no longer just aiming to be a car company. They're transforming into a mobility company. They're setting their sights on changing the future of transportation, offering people new and more sustainable ways to move around. So, how does this water engine actually work? At its core, it functions similarly to hydrogen combustion engines, like the one in the Toyota Yaris GR-H2. However, rather than using pre-processed hydrogen, this engine extracts it directly from water by creating a chemical reaction. Essentially, the engine uses electrolysis to separate hydrogen from oxygen in H2O molecules. It's an efficient process that powers the vehicle without producing harmful emissions. Here's where the technology gets even more fascinating. Toyota's water-powered engine uses a clever combination of components, including an electrolyzer, which is key to splitting water molecules. This electrolyzer takes in water and, using electricity, breaks the bonds between hydrogen and oxygen. Hydrogen is then used as fuel, driving the car's motor. Meanwhile, the oxygen is simply released back into the air. No pollution, no toxic waste. The motor converts hydrogen into electrical energy, powering the car's wheels. The power control unit also steps in, regulating the flow of electricity from the fuel cell and ensuring smooth acceleration and braking. This whole system creates a seamless driving experience while being environmentally friendly. Now, unlike hydrogen combustion engines and FCEVs, which need heavily armored tanks to contain hydrogen gas, the water-powered engine eliminates this hassle entirely. Since hydrogen remains stored within water until it's needed, there's no need for those bulky, heavy tanks. Hydrogen is notoriously difficult to contain, so Toyota's innovation lightens the load, literally, and makes storage much safer and easier. But the real magic happens when the hydrogen is separated from oxygen. Once that's done, the hydrogen is sent to the engine, where it combusts much like compressed natural gas. Just like CNG engines, the fuel injectors in this setup need to be adapted for compressed gas. This means Toyota's water-powered engine is not only efficient, but also built to last, with strengthened components that ensure it can handle the detonations safely. Now let's talk about the long-term benefits. First off, this engine is nearly zero emission. Much like electric vehicles, but with added convenience, it could be even more practical than any other engine types out there. Need to refuel? All you need is access to diluted water, which costs almost nothing. The implications are huge. If this engine catches on, it could drastically reduce our dependence on oil. In fact, the only industries that might still rely on fossil fuels would be heavy machinery and large power plants. Another key advantage is that this tech removes the need for mining rare metals, a highly destructive process in today's car industry. Mining for these metals pollutes water sources, contaminates the soil, and renders entire areas uninhabitable. In comparison, water-powered engines are far superior, even to hydrogen combustion engines and FCEVs. Storing water requires very little effort, while storing pure hydrogen demands strict conditions, high costs, and poses greater environmental risks. Hydrogen, as a gas, is incredibly tricky to contain. Any irregularity in a vehicle's tank can cause it to escape. That's why hydrogen tanks must be armored and constantly monitored. On the other hand, a water-powered car can store fuel in almost any plastic container, making it far more convenient and less expensive. Plus, storing hydrogen outside the vehicle is a nightmare. It needs ideal temperatures, indestructible tanks, and static conditions, all of which drive up costs. These challenges with hydrogen are the reason it hasn't taken off, and likely never will. It's expensive to produce and store, and that translates to a higher price for consumers. Now the big question is, can water-powered engines work for everyday driving? Absolutely they can. Contrary to what some might think, these engines aren't weak. In fact, they can match or even outperform most gasoline engines. In theory, water engines can generate up to 3 times more energy than traditional internal combustion engines, making them a serious contender. Plus, they're much safer. With no highly combustible fuels stored in the car, there's no risk of the vehicle catching fire, or worse, exploding like a bad fireworks show. What's even more impressive is how simple these engines are to produce. They have a relatively straightforward mechanical design, only slightly more complex than gasoline engines. This makes them cheaper and easier to manufacture than both electric vehicles and hydrogen-powered cars. And because they don't rely on oil, water-powered engines could be the perfect solution for countries that don't have access to rich oil reserves. One Iranian scientist, Aladdin Qasemi, proved just how feasible this technology is by converting his old Peugeot 405 to run on water. He successfully built a fully functional water-powered car in his own garage, showcasing how accessible and practical this innovation could be. Now imagine the potential if a major player like Toyota threw its resources behind this technology. Water-powered engines are not only easy to build, but also incredibly economical. Qasemi's Peugeot managed an impressive 30 to 40 miles per gallon of water, far better than the original gas-powered engine. If this technology goes mainstream, we could be looking at cars that easily exceed 80 miles per gallon, without sacrificing power or performance, making them one of the most cost-effective options out there. Furthermore, before Toyota embarked on its quest to develop cars that run solely on water, the idea had already attracted plenty of attention and skepticism. Back in 2008, a Japanese company named Genapax made headlines with their claim of creating a car powered entirely by water. They touted a special system that supposedly split water into hydrogen and oxygen, then used the hydrogen as fuel. It sounded like a game changer, promising a cheaper and greener alternative to gasoline and diesel. However, the excitement was short-lived. Experts quickly uncovered that Genapax's vehicle didn't run purely on water. It also required a special material called metal hydride. This revelation cast doubt on their claims. Scientists pointed out a fundamental issue. Water is stable, and breaking it down into hydrogen and oxygen requires substantial energy. The laws of physics dictate that you can't extract energy from water alone, because the process of splitting water molecules demands more energy than you can get back. Fast forward to today, and the quest for water-powered engines remains largely unfulfilled. With no mainstream versions available and no other manufacturers actively pursuing this technology, we're left to wonder, could water engines be the future of transportation? In theory, yes. Water engines could revolutionize the industry, but the road ahead is fraught with challenges. Logistically, water engines seem straightforward. No major infrastructure changes needed. Yet, the technology is still experimental, and functional prototypes have proven unreliable, with performance often falling short of expectations. The safety of these engines is another concern. The process of splitting water into hydrogen and oxygen can be hazardous, as hydrogen is notoriously difficult to contain. Even a minor leak can be dangerous. Moreover, if Toyota, or any company, successfully develops a reliable water-powered car, they might face pushback from powerful industries. The shift to water fuel would significantly reduce the need for fossil fuels and rare minerals like cobalt and lithium, potentially threatening the interests of mining giants and oil companies. These industries, deeply entrenched and influential, might do everything in their power to stifle such advancements. So, while the concept of water-powered cars is thrilling, the path to their widespread adoption is fraught with obstacles. Toyota's progress, if any, may well be under wraps to avoid attracting the ire of entrenched industries. That's a wrap for today. Don't forget to subscribe and turn on notifications so you're first to catch our next video. Thanks for watching. See you soon.